In this Godot tutorial, I'll teach you how to add background music to your game. And we won't be adding a simple background track. No, we'll be fading in and out different tracks based on the state that the game is currently in, whether the player is exploring or maybe being in combat. Let's get started. Now, before we can add any music to our Godot game, we're first going to need some audio tracks. Right here I got two different tracks in two different formats, WAV and OGG. And the difference between these formats is crucial for your Godot game. WAV format is basically an uncompressed audio file that your CPU can load almost effortlessly. Therefore, it is very quick and it's ideal for special effects, which need to load fast and which might require a lot of them playing at the same time when a lot of combat or something else is going on screen. OGG format, on the other hand, is a compressed file, so the CPU takes more time to load that up as it needs to unpack it first. And that's great for background music because the background music, of course, is not changed and loading and unloading that often. Usually you play a track for a couple of minutes. Now, you might wonder, why don't I just use WAV all the time if it's so good and so fast and takes no CPU power? Well, let's inspect these two files, which are exactly the same music file of exactly the same length. This is 40 megabytes and we're only talking 2.5 minutes of music here. Now, if we inspect the OGG file, we'll see that this file is only 3 megabytes. That's 13 times smaller. So that's a huge difference, and that will make a huge difference once you start exporting your game to, for example, an executable or an .apk for Android. You will make sure that the download or the total size of your game is smaller. Now, with two files, you're not really going to notice that. But once you got 50 music tracks in there, trust me, that is quickly going to add up to gigabytes. So you want to use OGG files for your background music. So we're going to take these two OGG files and we're going to put them in our game folder. So this is my Godot project. I'm going to put them in assets and in sound. Now, if you download audio music, you might only download the WAV format, but if you just Google for WAV to OGG converter on Google, you'll very quickly find a converter online that will help you out for free to turn your WAV files into OGGs. I've actually done that with these two tracks myself. Now, you also see that this has the looped name. Now, of course, it's just a file name, but what it means, or why I've indicated that, is that the end of the music track transitions very smoothly back to the beginning. So that's of course perfect for background music that you want to play on and on and on and on without the player really noticing any change in the background music. So once you want to implement background music into your game, you want to look for looped video game music. Now, as you can see, I got a lot of music right here, and I got a lot of different things in here with piano and, I don't know, romantic feeling and you name it. It's 8-bit music, it's rock, it's space, it's mystical, it's scary. All this music right here, it's 8 gigabytes of music. This is all available right now on a Humble Bundle deal if you're watching this before the 27th of May 2020. So if you want to get a massive discount on some great music from a single composer, so everything matches very nicely, make sure you check out the link down in the description below. In the end of this video, I'll get into a little bit more details about the license and that kind of stuff. So you make sure that you know what you're signing up for. Now, let's add some music to our Godot game. Now, back in Godot, I've opened up the sound folder in the file manager, and here we got both of our files. The first thing you want to do when you add any files to your Godot project is you want to inspect them, see if the settings are the way you want them to be. So selecting one of these files and going over to the import tab right here, we see that loop is on. Now, by default, I believe loop is on for OGG files, but loop is by default off for the WAV format. So if you want to loop WAV formats, make sure you turn that loop on. It's always a good idea to check both of your files or multiple if you have multiple files uploaded to make sure that all these settings are right, else you'll be searching for bugs in code which are not even in the code itself, you just didn't import them correctly. If you change anything here, make sure you hit that re-import button to make sure those settings are actually saved. Now, with that done, we have to take a look at where do we want to add these sounds, where do we want to play them. And this might seem like a little bit of a mundane question, but it's actually super important. I've got the game loaded right here. Going to our scene and going to our remote scene, we can see the nodes that are currently loaded. So currently we got the root of the game, we got our data import, that's our singleton that loads up all our data files from the JSONs we have added to the game. And then we have our map scene. That's the scene right here that you probably are familiar with if you watched any of my tutorials in the past. So right now we could add maybe these sounds to the map scene. The problem is if we were to transition away from the map scene, or maybe if the game starts and we would have a main menu scene, and then when the player selects new game or load game, we unload the game menu and we load the map scene. That means that every time we destroy one of those nodes, also the audio file players or the audio stream players that we add to it are also destroyed. That means if you want to transition nicely over from a game menu sound or a main menu sound over to the map sound when the player has loaded the game, you cannot transition or make that transition because the nodes are being destroyed. So ideally, you want to add your file music or your music files and your music players higher than the main menu, higher than the map scene, higher than any map that's loaded, pretty much all the way up there. So we have to account for that. Now, there is a plugin that I do want to mention because I know some of you are going to mention it in the comments. There is a plugin for Godot called Sound Manager. I believe 2.0 is out now and 2.1 is about to come out at the moment I'm recording this. It sort of is a huge singleton that plays music at the same time. So it's like a singleton on steroids, an auto-load script on steroids. We'll also be adding our sound through singleton, or we'll be coding it in a singleton, but it's not absolutely necessary to have that plugin to create nice transitioning sounds. You can also just change the hierarchy of the game, and that's what we'll be doing now because I want to make use of standard Godot in this tutorial and not force you to install any plugins. So we need to have a level in between here, and we need to add our audio files, and we need to add a singleton. So let's start it off by creating that extra hierarchy level in our node structure of the game. Basically, this is going to be the highest hierarchy. So I don't even want to put it in a scene. I just want to put it straight into the project itself. So I'm going to go for a new scene. I'll call that the game root. I'll add a new node, and that will simply be a normal node. We don't need this to be anything else. Normally what I handle in the game root is everything related to scene transitioning and sound. That's sort of like what I do with this node. We can start it off by adding our audio stream players to it. And let's rename these immediately. So this will be the background, and I'm just going to call this normal, but you might want to call this differently in your specific situation. And I'll add a second one, and we'll rename this to background combat. Now I'm adding two because I want to mix between two sounds. So I want to transition or fade one out, and then I want to fade the other one in, but this doesn't have a hard cut. So usually I transition overlapping with each other, so that once the decibels of one are almost faded out, the decibels of the other are already coming up. Thereby you don't really have any sort of empty moments in your background music. Now for the background normal, we're going to go to our assets, and we'll add our Secrets of the Kingdom audio file to the stream by simply dragging it to it. We'll do exemplary for the combat, but then we'll take Protection of the Kingdom, as that's more our combat, our upbeat soundtrack. We currently don't have to set anything in the settings right here, but we will need to set some settings once we start fading in and out with the mixer, but we'll get back to this node at that point. Now, finally, I'll rename this node to game root, so it is easy to recognize in the node tree. I'll save that, and of course, we'll also need to make sure that once the game root is loaded, that the map scene is loaded. Now, normally, like I said, you would do this through a game menu or a main menu, and then with a new button or a load button and all that kind of stuff. These are tutorials for the future. Not going to do that right now. We'll just add the instance scene of map scene immediately to the game root, so that that map scene is still loading whenever we play the game. Now all we gotta do now is change the default scene that's loaded when we play the game from the map scene to the game root. So we're gonna go into the project settings, and under the application here, the run tab, we right now here have our map scene as the main scene to load when the game is started up. We're gonna change that, and we'll navigate to our game root, and we'll change that to game root. Now with that done, all we have to do now is add a singleton where we can handle our actual code for the music. So we're going to do that by going to our scenes. I'll simply add a new script to this. I'll change the name of the script to sound, and right now we have a sound script. we are going to go to project settings, and under the auto load tab, I'll now find that sound right here, and I'll open this and I'll add this with the add button to the sound singleton. It was already in there from a previous attempt, I guess. I didn't delete it yet, but that's how you would add that scene, or that scene as an auto load singleton. So right now, if we were to play the game, and we're going to go back to this remote tracker to see what is loaded, we'll now see that we have our sound singleton loaded right now. We have our game root, which will have any sort of instance scene on top of it, a main menu, a map scene, anything else, a city scene, you name it, anything that you would call your main scenes. And you see that our background, normal, and combat audio stream players are right there. And whenever we change these map scene, I imagine this will be the wastelands, and you transition through a teleporter to the grass fields or whatever, you could change these map scenes out, but you would never lose your background, combat, and normal audio stream players. And therefore you can continue the background music even though the scenes are being changed. So that's the kind of behavior we're looking for, and this is how you can set that up. Now that we got this, let's start with some really easy stuff. Let's just make sure our background normal track starts playing whenever we play the game. Alright, I'm here on the sound singleton where we're going to be programming the fading in and out and changing of music. I've already added a couple of lines. We'll go over them together and we'll add some extra lines, and we'll do a first test. The first thing we do when the game has finished loading, we unready we define two variables. We are going to be defining the node references to the two audio stream players that we've put in our game root. So we're going to get the parent of the singleton, that is the main root of the game itself, and then we're going to get the node game root, and then background normal and background combat. And then we need the game state, and I called it game state. You could call it music state or give it any name that you want that makes sense to you. This is going to be what state the music should be in, and that's of course important because we need to know what needs to happen, but we also need to know when does it need to happen, or more importantly, when does it need to change? When do we need to change the music? And of course that means that whenever this variable changes from, I don't know, normal to combat, or explore to combat, as I'm going to be calling it, we want that to be recognized in the code, and then we want something to happen. We want music to change. The perfect way to do that is to use setters and getters, or in this case, a setter. So when we define the variable game state, we use the command setGet. Then we can define the function that is going to be setting the value, and a function that is required to get the value. Now we don't need the getter in this case, so we'll only define the setter function. So the set game state is going to be a function that of course needs a variable as input. So the new value needs to have input, else we cannot change anything, right? First thing we do is we change the game state into the new value. So that's how we change it. But the fact that it is changed also means that we can then run a function change the music. Now under change the music, what we'll do is we'll add a match command to it. And that match command is going to be matching the game state, the state that was just changed right there before we asked this change music command to run. We're going to match it to 3 different kinds of states that we'll be defining, that it can be in. The first one is new game, and then we have explore and combat. Now, of course, during the game we want explore and combat to constantly switch depending on whether the player is in combat, yes or no. But when the game loads, there's nothing to fade out. And because there's nothing to fade out, it makes sense that on a new game we only start playing music and we don't stop playing any other tracks. Now, to have the game load the new game music state or game state, under ready function, I call that function set game state, and I give it the new game variable. So then game state is going to be new game, change music is played, it will match game state, which was just changed to new game, it will find new game and it will have a match, and it will start getting that music normal, and it will use the function set playing on that audio stream player to true, and then the track starts playing. Now, of course, we also need to define, okay, the track is playing, we have our normal playing, so whenever we get into combat, we need to change that. So then we set the normal track to set playing false, and we turn the combat track back on with true. Now, of course, this doesn't have any fading in and out yet. That's going to be in the next part of this tutorial. But the first thing we have to do is recognize these states. If these states are going well, then we're ready to start doing some fancy stuff with the music. So the question is, how do we recognize that the player is in combat? Do we do that when he fires a projectile? Well, in that case, if the player is just firing into nothingness, maybe just testing out a new spell, you suddenly have combat music playing. That's not what we want. What we can be pretty sure of is that whenever the player starts hitting an enemy, the enemy starts firing back. Or whenever the player is in range of an enemy, the enemy will start attacking. And that's when combat starts. So we can go over to the script of George. George is our trustworthy enemy in this tutorial series, or the many tutorial series that we've based on this project. And he's been dying all the time. So yeah, we have to thank him for that. George has a match statement right here. This is his state machine. He has 4 states. He can be in his rest position, rest state, in his attack state. He can be searching for the player, and he can return to its spawn point, after which he will go and rest again. So whenever George starts attacking, that's basically when he sees the player, or when the player starts attacking him, then we can say, okay, sound, that's the singleton we call, and then we can set the game state. Now, I can't call that function right here, but I can copy it away from here just to make sure we're not making any mistakes. And we can set the game state on the sound singleton, and we'll add the combat call to it. Now, the George, the skeleton, or his buddy William, that's taking the same script, are going to call the sound singleton and going to change the game state through the set game function. That will call the change music function, and the combat music will play. But I would love for you to hear what would happen if I play now, but then I will destroy your eardrums. The problem is that this function lives in the process, so that function is going to be called if George is in his attack state, like 60 times a second or something like that. And we got 2 enemies, so that's going to be called 120 times a second. So that means that the track starts playing 120 times a second over again. So you're just going to get this, well, I'm not even going to try and attempt to reproduce that sound, but that's not what we want. We want change music only to play if the game state is different than the previous game state. So what we'll do is we'll run a function that if not the game state is equal to the new value, in that case we want this all to run, and else you can just pass. You don't have to do anything. So what we do now is only if the new value that's being pushed into this function is different, if it is not the same, so is different than the game state, then we want the game state to change. Then we're going to print that game state so we can verify in the output of the editor whether things are going well. And only then we want to change the music. So this way we have a method that we can call George and change some music playing. Now I'm going to put on my headphones. Normally don't do that in YouTube tutorials, but hey, the sound tutorial, you got to have some headphones, right? So as you can hear, we now have our background sound playing. And I'm going to be walking over to our skeletons, and our combat sound starts playing. Now when I kill these skeletons, we have the problem that our combat sound is going to be continue playing. Reason being is that we never set that game state from the combat state back to the explore state, where the combat music will be stopped playing and the normal music is started up again. So we need a way to recognize whether the player is out of combat, and that's a little bit more tricky than that may sound at first. So let's get over that together. Let's code that in, and once we have got that, when we're changing the music at the right moment, then we can start working on our fades in and fades out. Right, I'm here on the state machine of the enemy, the same state machine we've just used to set the game state for the sound player to combat. We're going to use the same state machine to determine whether we're out of combat, but we cannot use that with a script on this particular enemy, because it only requires one enemy for the player to be still in combat, and we don't want another enemy to signal, hey, I am out of combat, because we don't care whether the enemy is out of combat, we only care whether the player is out of combat. And it only requires one skeleton or one enemy to keep the player in combat. So what we have to do is we have to check whether a selection of enemies is in combat with the player, and we can verify that by saying If the enemy is either in attack state or search state, then we know the enemy is still in combat. Or the player is in combat too, because who else is the skeleton going to be in combat with? To do that, we probably do not want to go and check every single enemy on the map. I got a very small test map here for a tutorial series on YouTube, but you might have a very big map. It could potentially have hundreds or even thousands of enemies. If that's the case, you don't want to check every single enemy. You want to select a sample of enemies and check only that sample, because else you're just wasting processor power on your device. The way we do that is we're going to go over to the player scene, and on the player scene we'll add an area 2D. That area 2D we'll rename to combat checker, and we'll add another child to it, and that is going to be a coalition shape. For the coalition shape, I'm going to go with a circular shape, and by clicking on it I can set the radius, and I'm going to set that to about 1500. We'll save it, and now on the map scene you can see this is going to be the circle, so we're going to find every single enemy that is in that circle, and we're going to check that array of enemies whether their state is either attack or search. If one of those two is true, then we know that we're still in combat. We do that on the player script, but before we can actually write the code, we first have to set the area 2D, the combat checker, to only check for enemies. If we're just going to check everything, it's going to return tables and chairs and walls and chests and the player itself and projectiles, and then we're just populate this array just too far, and we'll also run into errors because a projectile doesn't have the state that we're going to be looking for. So we have already, in previous tutorial series, have set the layer number 3, the collision layer number 3, to be only for the enemies. That's only where the enemies are and nothing else. So we can say that on the collision, that actually we don't have to set the layer, we only have to set the mask. So the area 2D is going to be looking into layer number 3. It doesn't have to live on layer number 3 itself, it only needs to be looking into it. So now under the script we can paste the function that I've prepared for this. So the function is going to be in combat check. We're going to be calling this function from the sound singleton. We're going to set the in combat variable to false. By default we're going to be assuming that we're out of combat. Then we're going to retrieve the array of enemies that are overlapping with our area 2D. We use that to do that, we're going to get the node, the combat checker, and we're going to use the function get overlapping bodies. That's going to return all the node references in an array. The fact that it's an array means that we can now loop over that array of enemies, and for every enemy in enemies, we're going to check if the enemy state is equal to attack or if the enemy state is equal to search. If that is true on even one skeleton or one enemy, then we know that in combat is true. And the fact that we only need one enemy to be true, to be in combat, we don't have to check any of the other enemies anymore. Imagine that this array is filled with 1,000 enemies, and enemy number 2 has attack, that has its state in attack. Then we don't need to check the other 998 skeletons anymore, because we only need one skeleton to say we're still in combat. So as soon as it finds one skeleton, one enemy that has enemy state, attack or search, we're going to set combat to true, and we're going to break out of this for loop. Thereby we are skipping over all the other ones. We don't need to check them anymore. We are in combat, and we can save those resources for other calculations. Then we're going to return in combat to the singleton sound that's going to be calling this function. Now that we have a way to check whether we're in combat or not, we can go back to the sound player and set it up over there. To do that, I'm going to go over to the sound or the singleton script, and whenever the player is in combat or the game state is combat, the combat music is playing, we want to be running check combat. That's going to be a function that we'll be defining underneath here. What we do is we make a check, and that check is either going to be true or false. We get that by calling the player and calling the in combat check function that we just created a second ago. The player right here is a new line of code I've added, which is a reference to the player scene. So that's the node reference that we'll be calling. So I'm calling the function on the player script, and if check, this is basically, if you don't have to say if check is true, you can say if check when the boolean is true, if check is a boolean and it's true, this will be yes, and if not check means that check is false. So if check, if we're true, then we're going to yield the code for 1 second, and then we're going to call check combat again. So it calls back on itself after 1 second. So basically we're going to be calling the player function to in combat check every second. We're not going to do this based on delta on every frame, because that's exaggerated. We don't want the sound to be exactly right on the millisecond. When the skeletons are killed, then if the sound is turning down, fading out after 1 second, that's perfectly fine for some background music. We don't need that to be more granular. We don't need to waste more processor power on that. If, however, check is false, so that means we're no longer in combat, then we're going to yield for 1 second. We do that again because we don't want, as soon as the enemy has died, that the music just stops playing. You know, we want it to slowly fade out, and that fade out can start 1 second later. So in the worst case scenario, you've just killed the skeleton after this function call, and we'll start the fade out in 1.9 seconds in the worst case scenario, or after 1 second in the quickest scenario. If you want to change that, if you feel like spending more resources on getting this more granular, just change these create timers and these yields. Also, using yield right here takes a little bit more processor power than having a timer on the node tree that's just going to be looping over and calling a function every 1 second. That is a little bit more effective with the resources. I didn't want to do this because this tutorial is already going quite long. But if you want to optimize for performance, that's a good alternative. If, however, to continue, if not check, so if the in combat is false, after waiting for 1 second, we set the game state to explore. That means that we call this function, we set the game state, we change the music, and now match is going to find explore. We're going to turn off the combat music, and we're going to start the normal music. Now we can test this out. I'm going to put on my headphones again. We got the music playing. We'll quickly run over to these skeletons. They're finding us. Now we'll hide so that they can search for us. They'll stop searching for us, they'll return to positions, and our combat music is now gone. Now it doesn't match right, but with the fade-ins and the fade-outs, that will return back to normal. We'll check the same if we kill them, and if we kill the skeletons, we'll see that we return back to our normal, calm music. Now we can work on the fades in, fades out. That's a pretty short part, I think, and then we're done for today. To fade in and out the sound of the music, we're going to be making use of tweens. So I've added 2 tweens to the game root scene right here. I've added them under the audio stream players. I'm called them normal and combat tween, just like their parents are recognizable with normal and combat. On the top of the sound singleton, I've added them as variables and then node references so that we can access them easily. Now, before we're actually going to build some complicated tweens, we'll first set up the rest of the project so the tweens start working immediately and we don't have to go left and right all the time. First thing we want to change is we don't want to set playing to false on this script anymore, because we don't want the sound to stop abruptly. We want the sound to stop when the tween is finished with fading the sound out. So instead of the script or the match command calling the set playing to false functions, we want these functions to be called whenever the tween signals that it's done tweening out. We do that by going to our normal tween, or actually first to our game root. We'll add a script to it, and then we go to our tweens and we'll say that tween completed will connect, and will connect to the game root. Then we'll do exactly the same for the combat tween. And on these 2 functions, once you have them, I'll paste over them the functions or the code that we need. What we're going to do is we're going to check if the volume decibels is equal to -40 on the normal tween for the normal tween completed signal, and the background tween for the background combat tween for the combat tween completed signal. This sound -40 is the decibel value that we'll be fading out to. Of course, we're also going to be fading in sound, and that fading in sound is also going to have a tween completed signal. But we don't want the sound to stop, of course, when the sound has been faded in, because that's when the sound should be playing and not stopping. So we check whether the tween has tweened towards minus 40 decibel. Then we know it's a tween fade out, and then we know that we can set playing to false. Now, this also means that with this minus 40, that we want these background combat and normal, these audio stream players, that we want them to start at minus 40 decibel. As you can see, when I go to these audio stream players, the volume decibel normally sets to 0. 0 is basically normal amount of sound. It looks a little bit like unintuitive to be like 0 decibel. Sounds like very little, right? It's silent. But this is actually sort of like normal sound. You can go up to, I believe, plus 24. But if you want to fade out, you can go all the way to minus 80. Minus 80 is like absolutely dead zero, but you can't really hear anything from minus 40 decibels anyway. And because we're tweening, if we're tweening also from minus 40 to minus 80, there's a big gap of space there that you can't hear anything, but it does take time. So we have more control over the fade in and the fade out if we only tween to minus 40, and the stream stops playing anyway the moment it reaches minus 40. So it's off anyway, so we don't have to worry about that little bit of sound that would be left at minus 40 instead of minus 80. So now that we have set both of these stream players to start at minus 40 by default, we now have our volumes checking if we're tweening back to minus 40, and then we're turning them off. So with this done, we can go back to the sound player and we can remove these two lines from the script. Now that we got that, we can start building some of these tweens, and then we'll be done with this tutorial. So for these tweens, it might look very impressive, all these lines of code, but it's actually quite easy, and there's a lot of repetition in here. Let's go over it together, and then probably I'll be giving some tips left and right on what you might want to change, because some things I've done for the YouTube tutorial, and you know, it's also a lot of personal choice and in here. So let's go over it together. What we do, we start with, of course, the new game state that's going to be set on the ready. So the new game's match is found. First thing we do is we start playing that background music, and that's of course now going to start playing at minus 40 decibel. So it's almost unhearable. Then we're going to interpolate the property by calling the music normal tween. We interpolate the background music normal note. The property that we are going to be interpolating on that note is the volume dB. We're going to be interpolating that from the background normal volume dB current level, so it's minus 40 that we have set it to by default, and we're going to be tweening it to minus 10. I'm not tweening it all the way up to 0 because this is background music. In fact, this minus 10 is probably still a little bit too loud for your game. I'm tweening it to minus 10 so that you can hear it well on this YouTube tutorial, but maybe a value of minus 14, minus 13 is probably better fitting for background music, also dependent on the sound intensity of the track itself. We're going to be doing that in 3 seconds, and I'm going to be making use of a transport ease out. Now, what's that? There's a cheat sheet. I've talked about it before. The transport ease out is this one, so it's going to ramp up quickly with the volume, so it quickly brings it into a volume that we can hear with our human ears, and then it's going to slowly ramp up the last part when it's fading in. So that's the specific effect that I thought would sound good. Okay, then we're gonna start that tween, and we have sound, we have background music now. Then, of course, at some point we get into combat. Now, what you see for both explore and combat is that we're stopping all the current tweens. What could happen is that, you know, the player is running around, away from some enemies, so it's in combat. It hides behind a corner, enemies can't find him, and just when the enemies start walking away, the combat sound is fading away, the background calm sound is fading in. It picks around the corner, and the skeletons immediately go in their attack state again. What you want to have happen is that not all the tweens that are still playing at that moment, that they continue playing. You just want to stop all of them. The reason being is else you're going to get some weird artifacts, sound artifacts, and you might even end up with the wrong track playing at that specific time. So that's kind of important. Just stop all current tweens that are ongoing if the player manages somehow to have the code switch between different music tracks in a very short time frame. Then what we do, we first have to fade the call music out in case of combat. So we're going to take the normal tween, we interpolate the property of background music normal. We take the volume dB, we again take the normal volume dB, the current reference. So if in that case, that special case that the player is able to switch the background music in several cases, if the previous tween has only tweened it up to, let's say, -20, from -40 to -20, and then the player initiated combat again somehow, you don't want it to start at a hard-coded -10 like I would have done here, or maybe -14 that you would have chosen, because then you suddenly get a spike in your volume of your background noise and then a fade out, and that sounds very weird. So you always want to reference the current volume decibels, and you see that I do that for everywhere, for every single tween. It's kind of important to get a good feel of the background music. And we tween it down to -40. Remember that -40 is important because under the game root script, when the tween is completed, it checks if the volume dB is -40 to recognize when it needs to turn off the sound. So you want to tween down specifically to -40. Now we are going to do this in half a second in this case, because when the player gets in combat, we want the combat music to come in quite quickly, because it would look weird if the combat music is finally there when the skeletons or the enemies are already dead. So this needs to go away quite quickly, and we again use the transquart, that parabolic function. Then we start that tween up, we set the background combat music to playing, and we pretty much do exactly the same for the combat music. We go from -40 that it's set to by default, and we bring it to -5. You see, I use a little bit higher volume for the combat sound, as that's more intensive, and you can give that a little bit of extra intensiveness by making it a little bit louder. But again, this -5 is chosen for this YouTube tutorial. -10, -9 might be a better value for a real game. Also dependent on your the volume intensity of the recording of your soundtrack. Here I use a translinear, and I do that on purpose because, as you can see, I have no delay here. So the volume of the combat music is going to be fading in at the same time that the music of the normal track, the calm track, is fading out. So you have the, let's see this, let me do this correctly. Yeah, this one. So you have the combat volume fading in linear, and you have the calm music fading out transquarterly. So you do have a dip in the sound intensity, but they will be overlapping for a part as well. And that's mixing of music, fading one in over the other. And that's the reason why we use two combat stream players at the same time, or that we don't have one note here and simply switch out the audio track, because with one audio track, it's hard to mix anything. So when we got that done, we of course, after doing the check combat, and at some point the game states explore again, then we run the explore function, pretty much exactly the same. We're going to be fading out the combat music. We're going to do that in 4 seconds. So it's going to be, you know, combat is done, and slowly we fade out that music. So you see half a second versus 4 seconds is quite a big difference. And we bring back that normal music. For this one, we're going to be waiting for 1 second before it starts. This is a linear function, this is a transquart function, but you can see also here we have an overlap between the two, and we do create a musical dip, but that musical dip is a little bit smaller than the musical dip that happens here. And we want that because we want the player to be alarmed that combat is happening. It's player feedback. Music is player feedback. Never ever forget that. So with a bigger dip in the total music intensity, the player is more aware of a change happening in the environment. Here the total music decibels is less, has a smaller dip, but that's okay because, you know, its combat is winding down and we slowly go back into a normal game state. And also a difference, here we fade back to -10 decibels, where we're fading to -5 decibels. So that also means that we can we come from further away, let's put it like that. Now I'll play the game and you can hear it, but just before we do that, I want to emphasize that this is, first of all, personal. Second of all, it depends on your music track. Second of all, thirdly, I'm already at 3. You might also have all kinds of different situations where you might even want to put different tweens. When you go from a game menu, like a main menu, to the loading the scene, then that might even look very differently. When player uses a teleporter, it goes from one explore site to another explore site, that might look differently. Of course, Also, with all these tweens and timers, this 1 second yield right here is of course also part of the whole music fading in and out and the mixing. So there's a lot of personal preference in this code, but I think by fiddling around with the values yourself, fiddling around with the type of transchord and translinear and other type of transitions that you can get exactly the right feel. And you know, this is sort of like a script you can use to get started. Now, without further ado, let's play the sound, let's play the game. Let me put on my headphones. All right, let's redo it. I didn't have my headphones on, that doesn't work. So you can hear music is slowly fading in. Let's find ourselves a skeleton. 1 is enough for now. I'm gonna be hiding behind this wall, and we're gonna be checking out whether that music is able to handle peeking behind the wall when he walks back. So comet music is going away, but if I show myself, it very quickly comes back in. So the call music was about to come in, but then I'm peeking behind the wall and suddenly, like, we're getting the comet music back. Now when I kill him, of course, our music fades out. Call music comes back very slowly. There we are. The comet music is really coming in strong to indicate there's a change in the environment. The environment is aggressive and fades out slowly. So that's it. That's how mixing works. Like I said, I will talk a little bit about that game music bundle, 8 GB of game music with the same quality like this one, with a lot of loops in there. So it's great for background music for any kind of game you might be making. So stick around to hear a little bit about the license, how that works, and then I'll leave you to it. Now, for the license, it comes with a pretty sweet license, if I may say so myself. The license grants the buyer non-exclusive, obviously, and non-transferable, obviously, lifetime worldwide rights to use the music assets and multimedia projects for online video, so I can use it in this tutorial as well, websites, animations, games, and films. So that's pretty good. That means that however long and wherever you might move in the future, you can use this music in any of your projects that are both personal and commercial. So you don't have to worry about royalties or copyright strikes or anything like that in the future. If you got this license, you're good to go with this music assets. Now, of course, you can't claim the music as yourself, obviously. You can't register and sell the music on any store platform, which is kind of obvious. And you can't redistribute or sub-license the music other than as part of a relevant project. So this basically means that if your buddy says like, hey, that's a cool sound and music track, and you send it over to me, that's a big no-no. You can't do that. Well, I think that's kind of logic, and I'll be surprised to find a license where that would not be the case. And it also means you cannot distribute or sub-license the music unless it's part of a relevant project. So if it's a game you make and you implement this music track in your game, and you make, for example, a subscription-based MMORPG or something like that, then the asset has become part of a relevant project, and then of course you are allowed to sub-license, redistribute, ask a subscription fee or anything like that. So that's a pretty good license, lifetime, worldwide, for commercial projects. You're good to go. Now, what can you expect? Well, you can expect a lot. I'm not going to listen to every single track here with you, but this goes like the songs I just played. They are part of the Fantasy Adventure Game Music Pack. As you can see, we got some heavy themes here. We had Protection of the Kingdom. You can see you got a looped version and a normal version. You see you got a lot of loops in here. You also got, for the quiet themes, we use the Secrets of the Kingdom. So you can see you also have like 3 other tracks. You could put a randomizer in your code. You could randomize and randomly pick one of these tracks, add them to that audio stream player, and you can even have various audio tracks play in the background. What's more in here? Well, this is the Fantasy Adventure Pack. For example, you also got the Cosmos Music Pack. One I like, I think it is Space Discoveries, that I really like. It really puts you in a sort of like the cosmos sort of atmosphere where you are in space, some sort of space game, you're in a spaceship or something like that. If that doesn't sound spacey to you, I don't know what does. But I mean, this music goes all the way back even into the 8-bit era. So if you're playing on something like, I don't know, some retro 8-bit game, 2-bit game even, you're playing on your version of Mario, you know, this is like some awesome game music. And again, this is good music, and also those cosmic music. They also got the loops with it. As you can see, if I extend this a little bit, all these Cosmos loops tracks are also loopable, and that's pretty much the case for a lot of this stuff. Here you got even for the epic battle trailers, you can play one, but you got even the looped and you got no drums. So if you want the track without drums, he included those as well. Yeah, we can have a quick look at one of these as well. Well, that's obviously an epic battle sort of scene. So you can also use this for your combat scene, just like we used the combat track. Or also the protection of the kingdom track just a moment ago. So, like I said, maybe I'm rambling too much too far. If you like this music, check the link down in the description below for this humble bundle deal. You can get all of this music, I believe, for as low as, like, I don't know, I think I live in the EU. I think I paid €23 or something like that for the entire pack. So check the link down below. Lifetime, worldwide use, commercial projects, 8 gigabytes. I think it's a steal. That was it for today, guys. Hope you like it. If you did, smash that like button, hit subscribe. Don't forget that little bell icon to make sure that you don't miss out on the next tutorial. Now, I do want to continue this audio series, probably going to do some special effects tutorial as well, how you can implement that. I'm also looking at shader tutorials and lightning tutorials. So we got a lot of new stuff coming up on the channel soon. If you want to hang out, chat, and maybe watch my own game development that I do on my personal project, Soul Whisper, I live stream my own game development every Tuesday and Thursday. We usually get a couple of dozen Godot Game Devs in the chat. So if you want to meet some other game devs, have a group to hang out with, you can join me on Twitch every Tuesday and Thursday evening. Link and schedule down in the descriptions below. There's also a link to the Discord server down below. We've got about 100 game devs on there right now, helping each other out whenever they run into a bug or an error or something like an artifact that they can't fix themselves. So I hope to see you on any of these platforms or another tutorial in the future. And until then, keep on gaming, keep on coding. See you later, guys.